A new interstellar object, 100 times bigger and brighter than 3I-ATLAS, has been discovered, and surprisingly, it is also headed toward the Sun. Astronomers first spotted it on September 12, 2025, using the Solar Wind Anisotropes, or SWAN, instrument aboard the SOHO spacecraft. 2 days later, Australian comet expert Michael Mattiazzo captured a jaw-dropping image. Its tail is 2.5 degrees long, about 5 full moons wide, completely dwarfing the tiny tail of 3I-ATLAS. The International Astronomical Union has officially named it C2025 R2 SWAN after its initial designation, SWAN 25b. The announcement landed like a thunderclap, because first there was 3I-ATLAS, and now the arrival of SWAN R2 larger and stranger has astronomers asking hard questions. So, what exactly is going on in our solar system all at once? Is this a second probe, a relay, or something else entirely? At first, Avi Loeb and his team speculated it might have come from 3I-ATLAS itself, perhaps a fragment torn from a larger icy body, or even a scout craft, released by a technological mothership lurking far out in space. But senior collaborator Peter Wiese confirmed the truth is worse. They come from entirely different directions. SWAN shrieks in from Aquarius, while 3I-ATLAS emerged from Sagittarius near the Milky Way's core. Yet somehow, they are converging on the Sun at almost the same time. The timing is impossible to ignore. Both will swing close to the Sun in October 2025, almost side by side on a cosmic scale. At perihelion, SWAN will be about 150 million kilometers from the Sun, while 3I-ATLAS passes at 203 million kilometers, a gap of only 50 million kilometers, shrinking as their velocities change. Even more ominous, they will both vanish behind the Sun at once, hidden from every telescope on Earth. 2 interstellar visitors, overlapping orbits, 1 solar encounter, and no way to see what happens next. Now, if you compare 3I-ATLAS with SWAN R2, it feels like a warship next to a drone. Spectroscopic scans of 3I-ATLAS already stunned scientists. A solid nickel body with no iron at all, a metal blend found only in advanced industry, not nature. Inside, instruments measured a 10 gigawatt nuclear core, and its tail behaved like engine thrust, not melting ice emitting tightly collimated carbon dioxide at a steady speed, a pattern no natural comet produces. As 3I-ATLAS neared the Sun, its exhaust snapped from red to green at the exact moment its path changed, which Avi Loeb calls thrust mix modulation, the craft adjusting its burn as heating increased, with a color shift as visible proof. 3I-ATLAS was terrifying enough, but the real shock came with R2 SWAN. Loeb's team detected a silver plasma shield wrapped around a nickel-cobalt armored hull that completely dwarfs 3I-ATLAS. This isn't passive shielding, it's a living, electromagnetic barrier with energy levels off the charts, able to bend the solar wind and deflect radiation far beyond anything a solid shell could do. Its tail spans to full degrees of sky, about 5 full moons wide, roughly 100 times bigger than the thin plume trailing 3I-ATLAS. As it neared SWAN's glow flared brighter and shifted to a white-green, exactly as Loeb's sensors picked up tiny thrust pulses, confirming a precision plasma drive steering system. Its exhaust is a dense nickel and cobalt iron plasma mixed with carbon dioxide and carbon monoxide, a signature Loeb calls impossible without a directed plasma engine. Then came the most terrifying finding. The core. 3I-ATLAS shocked the world with its 10 gigawatt nuclear reactor, about 50 times the output of Chernobyl. But SWAN's plasma core outputs more than 10,000 gigawatts every second, a power level Loeb compares to 2 black holes colliding, scaled and contained inside a single machine. In his words, 3I-ATLAS was only the scout. SWAN R2 is the fortress, a nickel-cobalt plasma vessel with a power core beyond comprehension. Just when scientists thought they had seen it all, NASA and JPL analyzed the orbit and uncovered a staggering truth. SWAN R2 returns every 22,554 years to visit our Sun. This isn't a quick one-time flyby, it's a returning visitor on a cycle so long it stretches far beyond the entire history of human civilization. Its closest approach to the Sun will occur in October, the very same month 3I-ATLAS reaches its own perihelion, 2 objects with anomalous properties, passing near the Sun within days of each other, one on a hyperbolic flyby, one on a bound 22,000-year loop. For Avi Loeb, the question shifted from, is this the same object, to, is this a system? According to Loeb and his team, SWAN R2 is not a normal comet but an automated machine sent by an advanced civilization far older than ours. For them, a 22,000-year orbit would feel like a routine patrol. At near light speeds, time slows down for the traveler, so what looks to us like thousands of years could be only months to them. In this view, SWAN R2's return isn't a fluke, it's an appointment. But why return on such a vast interval? In Loeb's scenario, each passage could be part of a scheduled maintenance cycle, collecting superhot plasma from the Sun as fuel, adjusting huge sensor networks hidden around the planets, or downloading data from secret stations buried in the asteroid belt, under polar ice, or even inside planetary crusts. It might also check on parked spacecraft, refresh navigation beacons, or update star maps. The sun may act as a power source or a navigation beacon, and the 22,000-year loop gives enough time for new information to accumulate before the next pass. What seems to us an age-long mystery could be, for them, a regular service call, refuel, update, retrieve, and leave again on a timetable older than human civilization itself. Another possibility he suggests is that Swan R2 has come to deal with 3IATLAS. If Atlas was a scout, Swan could be the heavy lifter, arriving to collect its data, recover its power core, or destroy it before humans get too close. Some even imagine the two objects are from opposing factions of an ancient struggle, rival probes converging on our sun to control a critical resource. The sun's energy, magnetic fields, and gravity could be essential for stabilizing wormholes or powering galactic networks. What we see as sunlight, they may see as fuel. But archaeologist Graham Hancock's team has given more unsettling reasons. He has noted that the last time Swan R2 passed close to the sun was roughly 22,000 years ago, at the end of the last ice age, precisely when humanity began creating monolithic structures and the earliest star maps. The Great Pyramid, the massive stone blocks at Giza, the perfectly aligned shafts pointing to Orion, all of these may be echoes of an earlier contact, or at least an awareness of these cycles. In his model, ancient builders may have copied or memorized the patterns of these returning stars, encoding the arrival schedule of these probes into their architecture. The pyramid shafts pointing to Orion, the ancient calendars tracking precession. They may not be random cultural artifacts, but warnings and instructions passed down from a time when the last great visitor came close. This theory would explain the extraordinary precision of ancient structures, the sudden appearance of agriculture and mathematics, and the obsession with the sun in early civilizations. If Swan R2's route has been fixed for tens of thousands of years, then the people who built the pyramids could have seen it with their own eyes, blazing across the sky with a 5-moon tail, and built their monuments to mark its path. But Loeb challenges this theory and raises the obvious question, why now? After millennia of silence, there have been 3 anomalies in less than a decade: Oumuamua, 3IATLAS, and now Swan R2. Loeb believes this timing may be a reaction to us. For more than half a century, humanity has been broadcasting its existence to the stars, radio and television signals, deep space radar pings, the Arecibo message, and the twin Voyager golden records drifting outward as a slow expanding sphere of data. By now, those signals have washed over dozens of nearby star systems. In Loeb's scenario, that bubble of noise finally reached the right listeners, and their response wasn't a single craft, but a sequence. First, Oumuamua in 2017, a dark silent scout, then 3IATLAS, a nickel-bodied probe with a nuclear core, and now, Swan R2, a silver plasma fortress with a power core rivaling black hole collisions. Loeb suggests this is no coincidence. Our transmissions may have triggered a dormant schedule or reactivated an ancient surveillance network. What we see as comets may, in fact, be machines sent to audit a new civilization that has just begun shouting into the dark. The golden record was a greeting. These could be the visitors arriving in reply. Its emergence from the sun's glare is a stark reminder of how fragile our observational net still is, and how easily something vast can pass unnoticed until it's suddenly before us. What's striking is not only the object itself, but the broader silence surrounding these events. No government, no major space agency, neither in America nor in Europe, has yet treated such discoveries as matters of common concern. Official voices remain quiet, as if the less said, the less responsibility they must bear. And yet, the sky is not silent. Swan R2 and 3IATLAS are not just comets. They are signal signs of the limits of our categories, of the need for new frameworks, and perhaps of our own place in the cosmos that still resists us. It feels at times like the beginning of an ancient drama. The signs are there, but the chorus prefers silence. The risk is that by ignoring the oracle, we miss the lesson it carries. The cosmos will not wait for us. It speaks whether we listen or not. So, which theory do you believe? Routine maintenance, an ancient surveillance network, or a direct response to our signals? Let us know your thoughts in the comments. And don't forget to like and subscribe for more mysterious deep space investigations.